All right, in this next example, example 3, we take a look at a predator-prey model, an ecological model, and I think these are really neat examples. So let's take a look at this. In the study of ecosystems, predator-prey models are often used to study the interaction between species. Consider populations of tundra wolves given by W and caribou given by C in northern Canada. The interaction has been modeled by the equations, and then they go ahead and they gave us these two equations here, these two derivatives. So if and when you guys need to go on to differential equations, they're giving us a system of two differential equations. What's neat is you can work with an ecologist or biologists, and you can collect data on the two different species of animals, and you can go ahead and use that to calculate these coefficients, little b, and little c and little d, and those different constants there would help tie these two equations to make it really accurate for the two populations. If you have two different predator-prey species, then you're going to have different values of these coefficients here. But this is something that does get used in the real world, and it's pretty cool. And allows us to study population dynamics in wildlife just by looking at math and using some equations. So let's go ahead and take a look at how we can start doing this. For part A, what values of dc, dt, and dw, dt correspond to stable populations? So if we're talking about stable populations, this means we don't want the population changing. If the population is changing, then it's certainly not stable. Stable doesn't mean nothing bad is happening. It also means that nothing dramatic is happening the other way, necessarily good or bad. It just means it's static. So I'll just say here that stable, this means unchanging. And since derivatives are rates of change, if we want to know what values of these derivatives mean stable, in other words, mean the unchanging, well, if a positive value of a derivative means increasing and a negative value for a derivative means decreasing, if we want no change, we want the derivatives to be 0. So if stable means unchanging, this would imply that we want dc dt to equal 0 and dw dt to equal 0. In this way, they're in balance. They are in equilibrium. So I'll just say this. They are in equilibrium. If you do take a differential equations course and you do qualitative analysis, we would call the location for where this happens, the values of capital C and W where this is true, that would be an equilibrium point of the system. Okay. So part B, how would the statement the caribou go extinct be represented mathematically? Well, if the caribou are going to go extinct, that means their population is going to decrease. So at the very least, we would need dc dt to be negative. And if dc dt were always negative, then that means the population would always be decreasing until there were no more caribou left. So really, this is what we need, just that.